In this video, I'm going to be talking about how you approach texturing any sets and layouts that you're going to have in your animations. The main question you need to ask yourself when approaching this problem is what resolution are you going to be using in order to texture your sets in the most efficient way. This tabletop asset is going to demonstrate a very common problem that you're likely to encounter when you render animations. At the moment, this tabletop is using a diffuse map and a bump map, and they're both at 2K. And I've done a couple of test renders, and you can see that from this distance, everything looks absolutely fine. The textures look really good. But what would happen if the camera is to get any closer to the asset? Well, you can see that once the camera gets close to the asset, the textures look absolutely terrible because 2K simply isn't enough resolution to hold up once you get this close. In fact, we're zooming in on a very small portion of the 2K map because the 2K map is covering the entire table. So obviously I'm going to need to use higher resolution textures in order to allow for the camera to move freely in this set. But the problem I'm going to have then is that if I use 8K maps on all my assets, I'm not going to have enough memory to render because 8K maps consume a lot of memory. I'm going to switch to Photoshop to show you the difference in memory use between a 2K map and an 8K map. Now I should point out that all my maps are at 16-bit rather than 8-bit, and this is just so that I've got a little bit more headroom in compositing if I want to push things a bit further in Nuke, for example. Now 16-bit maps use twice the amount of memory as 8-bit maps, so just remember that proportionally the differences between 2K and 8K will be exactly the same. It's just that the 8-bit versions will use half the amount of memory. So here I've got a 2K diffuse map open, and if I go to the image size dialog, it will show me how much memory, how much RAM this image takes up once it's open. So here it's 24 megabytes for this diffuse color image. If I switch to the 8K version of the exact same map and open the image size dialog, this now tells us that at 8K, instead of 24 megabytes, the image is taking 384 megabytes of RAM when it's open. And this applies in Modo as well. And this is because every time you double your pixel dimensions, you quadruple the amount of memory that you need to use this map. So now that we've multiplied our pixel dimensions by 4, we need 16 times more memory in order to render this map. And the problem you have now is that if you're using 10 of these 8K maps in your scene, you need 3.5 gigabytes just for texture memory. 10 maps is nothing in a production scene. You'll find that you'll be using hundreds of maps. So how do you control the amount of memory that these maps are going to be using? Because you probably can't afford to spare 30 gigabytes for every single machine on your render farm just for texture memory. The solution to this problem is to use Mip mapping. And what Mip mapping is a file format with several layers of resolution all written to the same file. So if this texture was saved as a Mip map, the top level would have the full 8K resolution, and then another level below that would store 4K resolution, and another level below that would store just 2K resolution, etc, etc, etc. And as the texture is being rendered by the render engine, the engine decides which level of resolution it needs to take off the disk. If it decides it only needs 2K of resolution, it will pull just the 2K from the file. And that means it would only use 24 megabytes of RAM for this particular file instead of 384. And that means that you can manage your memory much more efficiently when you're using hundreds and hundreds of texture maps. So how do you go about creating a Mip map? Well, the good news is that you can do it from within Modo itself. So the first thing I'm going to do is to replace these 2K maps that are applied to this wooden table with their 8K versions. So I've located the diffuse color in the images list, and I'm simply going to go replace as still, and I'm going to replace it with the 8K version. Once that's done, I'm going to do the same thing with the bump map. Locate it, replace as still, and then replace it with the 8K version. And having updated my maps with the 8K versions, the next thing I need to do is to save them as tiled EXRs with Mip map levels. But before I do this, I need to go and check a couple of preferences. So I'm going to go to System, Preferences, and I'm going to go to Image I/O. And here in the OpenEXR export, I'm going to make sure that Generate Mip Map Levels is ticked, because that's what's going to allow us to write the several layers of resolution to the one file. Modo 801 also allows you to explicitly limit how much memory your OpenEXR tiles are going to use during rendering. So if you look at the options under OpenEXR Loader, you can limit the tile memory, set what this limit is going to be, and also cache the tiles to disk. So what happens when you limit the memory is that once your tile memory is exceeded, Modo will purge any unused tiles from RAM and only load them again later on if they're needed. If you opt to cache the tiles to disk, what this will do is that when tiles are purged from memory, they'll be written in an uncompressed format straight to a temporary file on your disk, and that means that they can be reloaded again much faster. So with my preferences now set, I can return to the Images browser and save out my images as Mip Mapped tiled EXRs. So I'm going to select an image, right click on it and go Save As. And as the image format, I'm going to choose OpenEXR tiled half. So the half means that it's in 16-bit rather than 32-bit, and tiled means that we can use all the options for mip mapping and OpenEXR tiling. So with this all done, I'm just going to hit save, and it's going to take Modo a few seconds to write the file. And now the bump map is saved. I'm going to do exactly the same thing with a diffuse map. I'm going to save it as, select OpenEXR tiled half, and simply save the file. Once again, it's going to take Modo a few seconds to write the file. And the great thing about doing all the work in the Images tab by simply updating the textures that were already there is that all the work that I've done in the shader tree, all the settings that I've applied to the textures, etc., have been preserved, so I don't really need to update anything once I've replaced the images. Before moving on, I'd like to say something about maps that use values instead of color information. So by this I mean bump maps or specular maps, roughness maps, etc. These should be saved out as grayscale maps from the original application that created them. So if you look at my diffuse map, you can see that's got RGB floating point after it, whereas my bump map just says gray floating point. And what this means is that it doesn't have 3 channels, it just has the one. So if I switch to Photoshop, you can see in my channels palette, I don't have RGB, I've just got the one grayscale channel. And this is very important because it means that you're going to be using 1/3 of the memory to hold this map. If I go to my image size, you can see that this is an 8K map and it's only 128 meg. If I compare it with the color diffuse map, you can see that that is going to be 384 meg. So that's one benefit of actually converting these maps to grayscale. If you ever find that you've got a map that should be in grayscale but it's got RGB channels, you should go to image mode and make sure it's set to grayscale to discard the color information, because that not only means that you're going to be using 1/3 of the memory for this map, but also Modo is also going to know how to correctly interpret this map as a linear map. So if I go to my image color settings, the color space of default for this grayscale map will automatically use the linear values that are contained within the map. And the reason this is important is because if Modo had encountered RGB channels within your map, it might have incorrectly applied an sRGB curve to them, which means that your values would be gamma corrected. Essentially, they would be being distorted. A grayscale map will always be read as linear, and you want value-based maps to be read as linear because otherwise the data contained with them is not going to be interpreted correctly. So now that we've got our maps correctly mip mapped with 8K versions available to us if we need them, I'm going to fire another render of this close-up to see if the quality has improved at all. I'm just going to pause the video while this renders. And with the render complete, you can see that when I compare it to the previous render, which was using a 2K map, the quality is now much better, because we're using an 8K map as the top level of a mip mapped file. So this means that our camera can get much, much closer to the assets without them suffering visually. It also means that we can apply 8K maps all over our set on all of our assets if we need to, without running out of memory on our render farm, because we're using the tiled EXR options to manage the amount of memory that Modo uses, and also the Mip mapping to control exactly what level of detail is loaded whenever an asset is being rendered. There is one thing you really need to be aware of though when using Mip Map files, and that is that in your image settings in the shader tree, anti-aliasing must be enabled. If you disable anti-aliasing, you'll also disable the Mip mapping, and only the highest level of the images will be loaded. That is the full 8K texture in this case. So remember, if you want your Mip mapping to work, you must enable anti-aliasing. Now, while a single 8K map is sufficient to texture this tabletop asset, when it comes to things like the walls or the floors, we run into problems because these items are much, much larger, so it's much harder to tile them with just one map. But instead of using multiple maps, because this is going to start taking up even more memory, Modo offers us some clever ways to use one single map on assets such as these, but tile them without them looking obviously tiled. And to show you how this works, I'm going to return to the scene. And in my shader tree, I've got the diffuse map for the floorboard selected. And if I go to the texture locator, you see that I've got it wrapping horizontally and vertically by a factor of 2. Yet, if I open the render window again, you can see that there's absolutely no sign of tiling in the floor. And this is thanks to a new feature in Modo 801, which is called Random Texture Offset. And I've got it set here to surfaces, which basically means that every single separate mesh in this floorboard layer is going to have a slightly different offset to the others, which means that essentially you can tile your textures without the tiling being really obviously visible. And this allows me to use a single 8K texture to cover this entire floor and still get the level of resolution that I need. And you can always increase the resolution by increasing the tiling. So for example, if I was to go to my latest render and look closely at this floor and decide, well, actually that's still not quite good enough for me, all I need to do is basically increase the horizontal and vertical tiling. Now what I'm going to do is I'm now going to open a new preview render and just set it to the original camera. And you can see when I compare it to this render we've got here, we've got a pretty different pattern on the floor. Let me just make this larger so you can see it more clearly. And we've got a different pattern on the floor with a higher level of tiling, which essentially is going to give us more resolution. But there's still no obvious sign of visible tiling thanks to the random texture offset. So this is a pretty handy thing to have because it means that we can really use a minimum of image maps and still get a lot of resolution and variety. And to see if this actually increases the quality of our texture, I'm going to fire off another render using the close-up camera and we can compare it with a previous render. I'll just pause the video while this is rendering. And here is the completed render. And if I compare it with the previous render, where the tiling was set to 2 rather than 4 like it is now, you can see that in the latest render, we definitely appear to have more resolution in the maps, and that's normal because they're tiling twice as much. So you can see that's another trick you can use in order to maximize the use of one image over a surface like this. And you can do the same thing on the walls or any large item that is there in your scene. You can just use one large map and make sure that it's applied to every surface with slightly different offsets in order to hide the obvious repetition that you would get with a tiling map.